set of technologies that I have been working with for pretty much the last decade or so. I'm going to give you a brief bio followed by a problem statement, and I will subsequently talk about the kind of problems that you will get into and some of the tools and technologies that are out there that will help you or that are trying to address the situation itself. I'm going to share my presentation and go off video so that there's a little bit of a bandwidth issue in case there becomes a problem. Okay? Let me know if you cannot hear me properly.
Yes, sir, you're audible.
Okay, how do I share person? I guess that's the, okay. All right, can you all hear me okay?
Yes, sir.
Very good. Okay, so a brief bio about myself. This is the agenda for today. I'm just going to, as I said, a brief bio followed by the business problem that we're trying to tackle, and what I have been working on for, as I said, close to probably since 2005 with some technologies while I was at IBM. And the use cases and some of the solution providers. My apologies up front if some of the material that is being presented is a little bit US centric, but the problems don't necessarily just stop at the borders in the US. It is a global issue. And as a matter of fact, that the technologies that I personally worked with were used and is likely still used whenever you apply for a passport in India, your information gets vetted by the technologies that I worked with. So without much ado, let me just give you a brief bio. As Neha said, I have 30 plus, actually close to 35 plus. I have done the gamut of a typical IT technical person, from application development to technical sales to technical education. And but a lot of my work for the first part of my career was focused on database management systems, and worked with distributed databases and actually large-scale data warehousing. Some of the, I mean, back in the 2000s or early 1900s, if you said you were working on something that had a few 100 million records, that was a large data warehousing scenario. But today we are talking about billions and billions of records. And the last decade, I joined a little-known database company called Informix back in '93, and which was acquired by IBM in 2001. And since 2005, IBM, when they purchased an outfit out of Las Vegas, Nevada, we didn't even understand. I didn't even know the issues related to entity resolution. And obviously, I've gained quite a bit of experience working with large-scale data, and particularly as it relates to entity analytics. My LinkedIn profile is on the screen, and I believe this is being recorded, so you should be able to get it as well. All right. So let's talk about the business problem, right? Bunch of statistics on the slide, and this one and next. But as you can see, there is a lot of fraud that happens. There's a lot of fraud. There's a lot of tax evasion, identity theft. This has been going on not just in the recent past, but for a long time. And the principal reason for some of this is lack of controls, lack of proper adjudication of information, lack of verification of information. There was no standards in terms of how data was collected. There was no methodologies in terms of how to compare and contrast information. And so criminals, and unfortunately, when you have such problems, you have to think like a criminal. And when we started looking at the data, the nuances in terms of how they actually manipulated information to basically perpetrate this fraudulent activity is outstanding in terms of in the sense that their brains, I mean, the way they went about doing this is very systematic, and they were able to overcome some of the pitfalls and in enterprise systems. Corporations unfortunately have enterprise amnesia because they typically work with siloed information systems, siloed data structures, siloed databases, and there is absolutely no understanding of what the left hand is doing in terms versus the right hand. So this is the nature of the problem that has plagued. And I'm just only giving you a sample of the possible type of, and some statistics. Obviously, I don't have enough space to put too many of these things, but you get the idea. I mean, you're talking billions of dollars and perhaps even trillions of dollars of fraudulent activity. And if you think that this is primarily an issue in the US, it is actually not. As you can see, I was able to dig up a few, at least one instance in the one situation with the Indian financial systems, as well as one from Europe. And we all of us are familiar with the Panama, the Paradise, and the Pandora Papers, where these exposés showed how people and organizations and use a hierarchy and a complex hierarchy of companies and other entities to hide wealth and to evade taxes. One of the things that most people don't necessarily understand is this is not just a financial problem or a healthcare problem or a tax evasion problem. It also has to deal with human trafficking, and it's very unfortunate. And I have a bit of a definition on what human trafficking is, but it is not just within the U.S., but it's global, and it's actually worse outside of the U.S. than inside the U.S. And the unfortunate part is the way these criminal masterminds and enterprises do work is to create fraudulent identities. And as you can see that in both these slides that I've talked about, the focus is that there are people and organizations that are involved in the transactions that they get into or execute that is the basis for all of this fraud. Okay, so this is the fundamental problem that or one of the fundamental problems that entity resolution tries to solve. And as you can, as Richard and Sneha indicated early in the introduction, the focus in today's world is data science. Let's there is plenty of data being generated, and the new mantra is effectively is to gather whatever data you can, whenever you can, and wherever you can. Whether the data that is collected is going to be usable or not, we'll just collect it. I mean, you had the big data hoopla from a decade or so ago, and it still exists. That didn't mean it hasn't gone away. Then there was this data. It started out with data warehousing back in the 90s, and then it went into data lakes, where we get data warehouses were strictly structured information. Then you got into data lakes, and now we have pretty much everything, including the kitchen sink, being collected, whether it is usable or not. And the expectation is that whether that somewhere somehow we can boil the ocean and be able to get nuggets of usable information, and that is a myth. It's just practically impossible to churn all this data to be able to create anything meaningful out of it. And so what has happened is it has led the way, and data science and data mining and data analytics is not new. It has been there for a long time, and it has basically evolved from one to the other, one decade or one generation to the next. And what the current focus is on is to build or use automated tools to be able to extract this knowledge from this large volume of data. All right. So where does entity resolution fit into the picture? Right. So I want to kind of define what we mean by this. Entity can mean many different things, but for the context of this speech and this presentation, I'm going to say that an entity is loosely defined as something that an object, if you want to think about it, or a collection of features that describe a person, a place, or an organization, or any object. And while I'm going to focus here, at least the examples that I've shown and whatever further discussion I'm going to go through is going to focus on people, it really can be applied to pretty much any type of entity. Okay, and the entity resolution problem process is not is suited to pretty much any industry. It's the primary impetus right now is on banking because of the fraud that happens there. Healthcare, where there is tremendous fraud, and in general, it also there was a trend to do what we call mastering of information or master data management of information, so that we have a single copy. And there are many styles of master data management, centralized versus somewhat centralized, and so on and so forth. But entity resolution is the basis. How these applications do entity resolution is unique to every one of them, but they all share a common thread. And so what do we mean by entity resolution? And entity resolution is the capability to resolve multiple labels when I say multiple labels, think about it this way. You have different source systems that contain information about, let's just say me, right? I interact with the, if you take a banking institution, I interact with the day-to-day banking folks. Then I may have a certificate of deposit, or I may have some other interaction with a bank where I'm borrowing a loan for my car or my house, and so on and so forth. Now, in the olden days, things were all decentralized, and they had to do a lot of research to effectively pull the information to make sure they know whether they're dealing with one person or different people. In today's world, entity resolution and mastering of information has come a long way, and that allowed us to do a better job. In spite of that, there are some mission issues that you have to look at. What do I mean by that? When I, when you're looking at whether trying to get somebody to give a loan, then you're interested in certain features or characteristics or attributable information about me. For example, my income, for example, the last few addresses that I've stayed at, how frequently have I been on time in terms of repayment of my EMI, and so on and so forth. But if I'm looking at it from a fraudulent perspective, hey, I need to be able to compare that the information I have with a fraud list. Well, if you look at the fraud list, the amount of information that is contained in the fraud list is barely minimal. Sometimes it's just a name, and sometimes you're going to have some other attribute, maybe a date of birth, but the information there is very minimal. So having a robust set of attributes in my master data management to be able to compare this to a fraud list it is a different problem altogether in terms of doing this matching across these disparate uh, databases, data lists, and so on and so forth. Now, to finish up the definition, so entity resolution is the capability to resolve multiple data points for individuals, products, or other classes of data into a single resolved entity, so that we have if you have ever looked at some of the rhetoric from many companies around master data management, they also always say, we want to have a 360-degree view of the entity or the customer, or and so on and so forth. I mean, that's an overused phrase, because typically they don't, the mission is going to be different for one business operation versus the other, even within the same enterprise. Okay. In the as I said, the focus lately, even in terms of big data, or data science in general, is is more about similarities, right? Similarities in terms of the behavior of the underlying entity, or perhaps if I have transactional activity, predictability. So if I give someone a loan, what is the chance that this person is going to default or not pay their money, or not pay their EMI on time? What is the potential value of my giving this person a loan, or the risk in terms of giving the loan? Or if I were to purchase a property, for example, what can I predict to be the potential buying price or selling price of a property in a neighborhood, and so on and so forth? And that requires a lot of statistical information that needs to be collected in terms of past sales and so forth. And that is all about transactional activity and transactional behavior. When we talk about entity resolution, we're not interested in the transactions per se, but we're interested in the people performing those transactions. And unless you have a better handle on that information, it's just not people, it could be any entity type, but as I said, we'll focus on people. Unless you have a better way of managing that resolved entity, you're not going to have a better understanding of the transactions that they perform. I'll give you a very simple example. In most banking institutions, if you transact, and I'll talk about from a U.S. perspective, and I'm sure there is an Indian banking system perspective as well. If you transact over a set threshold, for example, $10,000 on any given day, then that transactional information has to be reported or has to be analyzed to find out if there is some laundering going on, or more importantly, that because it is a large sum of money, it has to be reported to the authorities, and so on and so forth. Now, if I'm a smart person and I have 3 separate accounts, and I send 3,000 from one, 3,000 from the other, and 4,000 from a third account, all of them belonging to me, they are 3 separate transactions. So if you look at it from a transaction-centric perspective, that person has not done anything illegally. But if you look at it from an account perspective, from an entity perspective, it is one person sending 3 transactions totaling $10,000, not 3 separate transactions which are below the threshold. So its transactional behavior is the focus more on the data science part, whereas the entity resolution is looking at it and saying, are the 3 people who sent these transactions the same? Okay. Feel free to ask questions in between, or I'm going to have a Q&A session at the end as well. All right. So when we talk about big data, the common theme is we are going to have the 4 V's: the volume, the velocity, the veracity, and the variety. What do we mean by this? Volume is just how much data is being collected. We know that in today's world, we're collecting a whole boatload of data. I mean, it is a massive amounts of data. I mean, if you look at some of the, I mean, I don't know if you guys followed the James Webb Space Telescope, the launch and the information that it is going to provide in the future. It is going to be in the petabytes or even larger than that. I mean, the current work that they're going through, it has collected so much data, it takes a while for the data that it has already collected to be sent down to Earth, and it requires storage. So there's tremendous amount of data that is going to be that will need to be processed, and the next part of it is the speed at which this information is being sent, right? So that's also an issue that you have to look at. Uh, for the business problem that we have, the key here is veracity. Veracity basically means how truthful, how much can I trust the information. So you're going to have data that will be a mixture of reliable sources of information and some that may not be as reliable. You need to take that into account as well. And last but not least, the variety part, you're not just going to get alphanumeric strings of data. There's going to be a lot of binary data that will be collected, images, sounds, and so on and so forth. I mean, if you just look at Twitter and Facebook and Instagram and Google and Amazon, there's millions and millions of transactions each and every day just in the US. And if you compound that across the entire world, the amount of data that they have to process is ridiculously large. Okay, and there's so much information that they have to maintain as well. So how do you keep up? I'm going to give you an example of the velocity problem itself. Okay, now in my apology if you are not familiar, but I will try to, or if you are familiar, but I'll try to explain the theme here. There's a game called bingo where it's a 5x5 square where one person just calls out a number and you just have to get it vertically, horizontally, or diagonally, right? Very simple, can be easily done, and it's a game and that a lot of people play. And what happens if I change the rules and say it's no longer going to be a simple 5x5, but I'm going to have a larger 100x100 card, but not only one, I'm going to give you n number of these cards that you have to simultaneously maintain. Perhaps, if it is the number of cards are small enough, you might be able to do it. But what happens if instead of one person calling out numbers, have multiple people calling out numbers and different types of noise and other information is also being pushed down this funnel. Now, this becomes a complicated problem because the more information, and all of this is akin to the types of data that we collect, and the more the information that you collect, what you're going to get is information overload. Okay, effectively, there's so much data, you don't know what to do with it, and you need to have some context around the data so that you understand what is usable and what is not usable. And what do we mean by context? Well, context is, if you think about it in a simpler way, if I give you a piece of information, just given that little set of a small picture or a small set of pixels that represent a picture, it looks like an eye. I don't know how to identify this, but if I give you more information, that basically says, hey, this is the eye of the Mona Lisa. So the rest of the information around that little piece of information is the context. It is clarifying that information. And context is very important because context is how, from an entity resolution perspective, you know what is important, what is not important, and you're able to discard the things that you don't need to worry about and only focus on the things that you want to. Okay? Now, one of the hooplas is around big data is yes, we are going to collect all of this information and we are going to boil this ocean and discover insights. It is an unfortunate assumption. And because if you look at the overall universe of data, what is available that to be absorbed is a very small percent of it. And the insights that you're going to get out of this observable information is extremely, extremely small. It's a microcosm in the when compared to the overall data that you collect. And unless you have contextual information, it is very difficult to actually get this insight. And we'll talk about what we mean by observable versus imperceptible and so on and so forth in just a second. Okay, so let's see how we might actually get through and understand the insight. So I spoke about the information overload, and some of it is also can be overcome with today's technology itself, right? We're not panicking anymore in terms of the overall data that is available for us to do something with it. But again, as I said, there is this fundamental assumption that we're going to boil the ocean, right? And let's just figure out how some of these, how it translates, or what the role of different components are in terms of trying to get to this insight. Um, the insights come from information, okay? But not all information will deliver insight, because if you look at the overall universe of data, there's observable data versus imperceptible data. What do we mean by observable data? Observable data is pretty much information that we can access from it, right? There's, if you look at the machine, the IoT data that is streaming across, most of it is garbage. But and because if you're looking at it from a signal perspective, only the ones that actually is an anomaly that is more interesting in that. But to find that anomaly is not very easy. Okay, and so you have to collect a lot more information and then discard what is not needed. So observable data is things that we can actually access, and only you get the insights only from within this observable data. Things that we can see are imperceptible, and while it is perhaps possible to at some point in the future be able to capture the so-called dark data, it is for now eluding us. Elucidated. What do we mean by elucidated? Elucidated means that the data that we do get from the observable data must be interpretable. Interpretable, basically, I need to be able to explain. If it is not very clear, then I can't use it. I'll give you an example. If I just give you a sequence of numbers, 10, 12, 14, 18, 20, 25, etc., and nothing else about it, you have no idea what to do with it. And so this is where context comes in and says, okay, this is representing the ages of the people in some population that we are looking at, right? So now that basically is no longer obfuscated. It is now elucidated, which means it's explained. And from within all of this, you're going to be able to still, as I said, only figure out what can be usable. And from within that usable data, you get a signal. And that within that signal, you have to now be able to qualify it further so that you're not basically going to use things that you're not going to need, and then ignore things. One of the key things that you also have to look at it is temporal and geophysically qualified signal. I'll give you an example. If I had a credit card that was charged in two different places at the same time, okay, let's say I'm in India right now and my wife is somewhere else. We have the same credit card and we have each our own, but the number on the same is the same on both credit cards, and she makes a transaction in the US and I make a transaction in India. Now, is that fraud? How are systems going to be able to detect that? right? So now that's pattern analysis that they go through to find out if I have used the card here in one place versus the other over the past certain amount of transactions, perhaps going back 24 months. So if they see that pattern of behavior, they're going to be able to go and say, okay, this is not fraudulent. Otherwise, they may choose to say, hey, there's something wrong with this. So bottom line is, even though there's so much data that is available, ultimately the amount of data that we can use is very, very small. And from an entity resolution perspective, the concept that we would go through to do this entity resolution is called context accumulation. We have all done puzzles as children, right? We don't necessarily, if we had a lot of these puzzle pieces, there's no way you can just throw all of the pieces onto the table and then automatically say, I'm going to do abracadabra and everything is going to be resolved, right? Into something that is meaningful. That is not necessarily possible. So what you do is you work with one puzzle at a time and start building it piece by piece. And that is what you're doing there, and what you were doing there in the past is called context accumulation. Similarly, when we talk about entity resolution, we're going to use the underlying concept here to say, as and when I get new data, I'm going to use additional context about what has just come in, compare and contrast to what I have already, and incrementally build up that information. And if I make an error doing it, it's okay, because I can go back and fix it the next time I get information. So there's this constant churn of false positives that might happen, but more importantly, what we want to do is to favor what's called the false negative. I'm happy to go down that road, but it's in the interest of time, I will defer it to perhaps a Q&A, or give you some additional pointers on where you might be able to look for data. Okay. Now, the identity problem. Okay. All of this leading to what we are going to try to do. There are a variety of challenges in trying to establish what the true identity of an individual. I've briefly mentioned it. You have different data islands and silos. There's different business processes that varies in terms of the style and the quality and the quantity of information that we collect. There's tremendous data drift because there is going to be changes in everybody over time in terms of their events. There's going to be natural variations in the data. And even in India, and particularly outside in a cosmopolitan country like the US or Europe, there is a melting pot of cultures. And to be able to understand the significance, and I'll briefly show you a couple of slides here shortly on what I mean by understanding having an understanding of the name culture, so that you can properly do matching of information. But more importantly, the worst kind of situation is there's going to be purposeful misrepresentation of information from in many of the different channels. I was working for a bank once, or working to implement at a bank, where this one unique scenario happened where the bank thought they had 13 different people, but we showed them that it's the same person who had 3 different variations on the name, 4 different addresses, 5 different variations on their date of birth, and some minor perturbations of one of their key identifiers. So you have to be vigilant of this purposeful misrepresentation. And it's even more important from a national security perspective, because you have to take all of this data and make sure that to get a better picture of your potential terrorist, for example, because there's going to be bits and pieces of information that you're going to be able to collect from the various channels, and to be able to piece all of them together is going to be a key component or a key requirement for entity resolution. Okay. So in terms of what kind of data that do we get, I mean, most from an entity resolution perspective, the key things that we are looking for is obviously names, the addresses, and I say plural because it is no longer, I had just have one name, right? Each of us will have some variations of our names, and we could have a nickname, we could have a married name, we could have other aliases that we choose to. So if you look at it from an entity perspective, it is no longer just a single name. There's going to be multiple names possibly that we might end up finding or discovering. There might be natural variability in terms of people moving from here to there, their addresses. We group certain things into personally identifiable information, things that are supposed to be unique for the individual, such as in the a PAN number and other. Even a PAN number, I believe, you can have multiple PANs, one for your business and one for your own personal need, but they are distinct, tied to distinct entities. There are other things. I mean, things like date of birth and gender, for example. It is not unique to a person. I mean, most people, there's a number of people that are going to be born on the same day, and right now, if you look at the statistics, male, female, and I believe the transgender is now an allowed name or gender type in India. In the U.S. and other European countries and whatnot, they recognize close to 20 plus different types of gender categorizations. Okay, we have to be able to understand that. How do we take that into account, and so on and so forth. And there's a lot of other information I just collectively call baggage. And what I mean by baggage is attributable information that might add value for an entity resolution process, but is not critical information. Because one of the things that you have to do as part of the overall process of entity resolution is to understand where the data came from. You need to have a tether to the source. If you don't have a tether to the source, from an enterprise perspective, if something changes in the source and you don't reflect that in the resolved entity scenario, you're not going to catch that update. How do you know which record to update in your system? Well, you need to understand that tether. So instead of going back to that operational system on a regular basis, you might want to capture some information, some feature or attribute about that individual from that operational system and keep it in your resolved entity record as well. Names are a problem. And if you don't know this gentleman, he was one of the 9/11 hijackers. Okay. And his name written in Arabic is right here. And this is roughly his anglicized name. But if you look at how that information was presented to the various organizations or entities that he interacted with, look at all the variations in the name. If you don't have an engine that is doing the entity resolution, understand this particular type of variation in information, it is going to be difficult to resolve all of them into a single entity, right? And even though you may have similar other attributable information, you may not be able to positively say that this is the same person. And another example here, transliteration and transcription of names are a problem, right? I mean, you have this Arabic name here, but depending on what part of Africa you're from, you're going to have various different translations of this name. And some of the name parts may actually not even be associated with the name. For example, the word Hajj, all that means is that person has been to Mecca. It is not part of the name itself. And so to understand this, you need some sophisticated name comparison and name matching technologies as well. Names in India are even more complex. I mean, I just looked up some names, and here are a few. you actually have an instruction for filling out the form for filling out your name for application for a PAN card. If you have to have an instruction booklet or an instruction pamphlet to actually to describe how to fill your name, that is a problem in the sense that because we don't have any kind of standardized ways of doing writing names. There's no dictionary of names, right? So name matching is a very, very, very difficult but integral part of the entity resolution process itself. When I was in India 30 odd years ago, I was in the South. We never had a concept of given name and a surname. Okay, we just had a name. I attached my father's given name's first letter as the initial. That's it. Obviously, when I had to go to the U.S. and I had to apply for my passport, I have to provide a given name and a surname, and that presented a problem. And what was going to be my given name and my surname? Well, you could choose to say, my given name is Muralidharan, but I've always been known as R Muralidharan. How do I translate that? So you make some decisions. And when you make these decisions, you have to continuously propagate that and make sure that you're able to compare R Muralidharan with Raj Muralidharan, with Rajamani Muralidharan, and so on and so forth. So again, what I'm trying to address here is the fact that technologies that need to play to understand names is very critical. Richard, can I go for another 5 minutes and then we'll do Q&A?
Yes, sir. Sure, surely.
Okay. All right. And so names and computers obviously don't mix well because of the various reasons that I've shown here on the screen here. A language is very ambiguous and unpredictable, whereas computers are fairly deterministic. Okay, I mean, it's a 2 + 2 is always 4, right? And but when you're looking at name comparison, Myra Smith and Maria Smith could be two different people, right? It could be a spelling mistake, or it could be two different people, and so that's why I said the answer depends. And so, what are some of the methodologies that have been been in place for a long, long time? Okay, for a long time, proprietary applications were ruling because there was not enough data to do that, and so these applications used homegrown code to do the record matching, but they could only do it one record at a time. If you were to say I need to compare one record to 1,000 records, then the homegrown application would iterate through the entire 1,000 records to make the comparisons. Then you had indexing systems and so on and so forth. The data was all over the place. When back in the 60s, when you only had an 80 byte punch card, they had to compress information and storage was very expensive. So when you had fields that were database fields, for example, even back then, that data had to be compressed into that 80 byte punch card. So what happens is data got overloaded. The same field had multiple pieces of information. So data quality became a problem. So then came along data quality and integration tools to be able to do that. And what they did was they said, we can do data deduplication. And that was the big deal, and say, okay, we have deduplication tools. Well, how do you deduplicate? If I have variations, fuzziness in my data, some spelling mistakes, how do I now then figure out which one is the right one? So survival of the record became an issue. So then you brought in master data management systems, where you had the ability to have some kind of a human being go and decide if which of the ones of the two records that have some similarities in information do I survive. And then you had purpose-built just entity resolution tooling, and they were focused on not necessarily mastering information, but more on doing this context accumulation type of activity, so that their mission was slightly different than mastering of information, and they operated a little bit differently. These resulted in different types of data stores. Master name indices are used in a lot of police environments where if you had a criminal that, or if you had someone who basically he was booked by a police station or that they had a record, well, they would basically put that information, do a search. They would do a search and say, okay, do I have this person already in my system? If not, I'm going to add to my master name list of people that I have arrested, and so on and so forth. Resolved entity databases built upon that and say, okay, I'm going to take these master name indices and then deduplicate somehow and have a better way of understanding that Mike is the same as Michael and Rob is the same as Robert, and so on and so forth. How do I visualize this information? Now, then came link analysis tooling. And link analysis tooling allowed us to be able to drag and drop things on the screen and then collapse them manually as well. But again, this is visualization. Today, there's a lot of graph databases that try to do entity-to-entity relationships and be able to navigate the chain of command or the n degrees of separation from one to the other. But graph databases focuses not on entity resolution. You can take resolved entities and then put it into a graph and be able to do some graph analytics on it, but graph databases by themselves don't necessarily do what is needed. Last but not least, there's this big debate about which is the right methodology, probabilistic versus deterministic. Probabilistic uses a statistical approach in measuring the probability that two records represent the same individual. And deterministic is slightly different. That says, typically, I'm looking for an exact match of the data. In the probabilistic world, you need to work with a sample to be able to build the algorithms. In the latter, in the deterministic, it is typically it's a rule-based engine that says if A equal to B and C equal to D, then it is probably the same individual. And then there is a mixture of deterministic with some probabilistic tendencies and so on and so forth. So there are different types of algorithms that are behind the scenes in going through the entity resolution process, and this also leads into what do I want to do, mastering of data, or am I going to do entity resolution? Again, as I said before, the missions are different because mastering data is more about making sure that my banking customer is happy and I have all the attributes and particulars about him. I know when to call him and when not to call. Entity resolution, on the other hand, says I want to make sure that I don't knock on the wrong door with a police warrant, right? So two different missions. Different trade-offs in searching is going to lead to different types of implementations of these entity resolution technologies, different user requirements, and there's a trade-off between getting the data you want versus avoiding the data you don't want. It's equivalent to fishing with a line versus fishing with a net. With the line, you only got to get only one fish. But if you were to get and you're saying, hey, did I get the right fish? Or if I'm do fishing with a net, I'm going to collect a lot of data, a lot of false positives, along with what I really need as well. So these are kind of the business implementation thoughts and processes that go through. Privacy, absolutely critical to make sure that the data is private and secure. A lot of privacy, personally identifiable information are collected by enterprises, and unfortunately, there are multiple copies of our own data within the same enterprise. I mean, I'll give you a simple example, not to belabor the point. Airtel, I have an Airtel phone here. I paid my account 10 days ago. I still keep getting a reminder from a different part of the Airtel business saying you haven't paid. Okay, so my information is partially copied, not fully copied. They don't have any idea that I've already paid my account. Poor way of doing business. Security of the information, it has to be taken into account because there could be potential misuse of the data. Every day in the papers you see identity theft is going up, and I showed you one of the very first slides where the identity theft is a very huge 4 billion plus problem. Okay. I have a link here. Jeff Jonas was the founder of the technologies that IBM purchased that I had worked with for about 10 plus years. And he's since left IBM and started another venture. This is fascinating technology and a fascinating way of working. His mind is just an unbelievable web of ideas. And feel free to go take a look at it. And he has a lot of thoughts about privacy in the era of big data. Multiple use cases. Again, even though I put a $ in there, this is no longer just a US-centric thing. All of these are absolutely usable in every industry in every part of the world. Okay. Here's a small list, a partial list of providers that work with or do have solutions in the space. I am most familiar with the IBM technologies called Identity Insight and Global Name Management. Sensing is an offshoot of Identity Insight. It is as I said, Jeff Jonas left IBM to start Sensing, and it's the next generation of the technologies that I work with. There's a mixture of ETL vendors here as well, extraction, transformation, and load vendors, plus master data management and purpose-built matching technologies in this list as well. And this is not a complete list. I mean, there's probably hundreds of companies and a lot more open source companies as well. All right, with that, I'm going to stop speaking. I'm going to stop sharing. And I'm happy to take on some questions.
Hello, is there anyone? Hello. I saw quite a good amount of raised hands during the session. So, if anybody would like to ask any question, kindly proceed.
Yeah, feel free to reach me via LinkedIn as well if you have questions. We don't need to just limit to the conversation here, but Richard has my email as well, so feel free to reach out. I'm happy to help. I mean, I'm sure there will be opportunities to explore around this topic, and if you need some guidance on places to look for information, I'm happy to provide as well.
So, which tools would you suggest, like for a beginner to get started with, if you want to like suggest it for the students?
So here's the problem, right? A lot of these things are not free, right?
Okay.
Because these are commercial organizations. I know with Sensing, for example, they do have a free download. Oops, sorry. I don't know what happened there. Suddenly, my background became dark here. With Sensing, I know they have a free download, and I think for a small amount of data that you can work with, you have the ability to download it and work with it for free. It is possible that there are others. There are some open source tools that might also be free as well. The thing with open source tools is they're not going to be as robust as the commercial ones. There will be some limitations, so they're not practical for large data analysis, but at least you will be able to utilize the basic understanding of the problems that surrounds the entity resolution process.
Okay, sir. Anybody? Any doubts? Wants to ask any question?
Sir, actually, I wanted to ask one question.
Sure, go ahead, Ashish.
Sir, I just wanted to ask how do see there is a lot of data, right? So how is the accuracy of this data provided by the organization? How can
So,
we determine the accuracy basically?
okay. So when you talk about accuracy, so you have to figure out if it is data that is collected by the enterprise, okay, you don't necessarily have any additional information to validate that. But there are, at least in the US, there are plenty of third-party providers of data that have that they themselves have gone through the process of entity resolution, so-called data bureaus, right? So, for example, if I'm going to apply for a credit card, it has to go through multiple levels of checks and balances, right? One of them, they're going to have these credit reporting agencies that will have collected information about my past behavior in terms of how often I have repaid and so on and so forth. So they will have demographic data about myself. And there's just not one organization, there are multiple organizations. So what enterprises typically do is to also go and purchase this data. Well, when you have 300 million people in the US, and the data providers probably have billions and billions of records that describe these 300 million people, you're not going to download and buy this 300 the entire data set. What you do is on demand say, okay, here's a piece of information, perhaps a name and a driver license or a social security number, and they will do a one-time inquiry into these data credit bureaus and these data providers, and they will do a data dump just about myself, which they will then use it as a third-party verification and validation source, and that will then get combined with the entity, the data that is collected by the bank, to be able to validate that information. Without that external validation, the banks or the enterprise can only rely on the information that they collect. And there is no way that, for example, Citibank and Chase are going to commingle their data to figure out if I'm a customer of theirs or if I have committed fraud within the other system. That's corporations are going to not be willing to share that information. Does that make sense?
Yes, sir. Thank you, sir.
I would request all to uh, switch on the cameras so that we can take a group pic. That would be great. Okay. Yes, I've saved it.
Excellent.
Uh,
Uh, Sneha, you can proceed with the closing ceremony.
Yes, sir. Thank you so much, sir, for this wonderful talk. I think we all got really inspired and encouraged to do a lot of research from our end about this topic. So, on behalf of VESIT, IQAC, and Research Forum in association with Institutions Innovations Council, I, Sneha Karthik from Department of Computer Engineering, is honored to give the vote of thanks for the inspiring talk on innovative approach towards entity resolution. Who is who and why is it important? By you, sir. It has been very encouraging for all of us present here. We're thankful to you for taking out the time from this very hectic schedule to be with us and enlightening us with the knowledge about this wonderful innovation and about the work that we can do and the research we can do about this topic. I would also like to take this as an opportunity to thank our principal, Dr. J.M. Nair, our vice principal, Dr. Vijay Lakshmi, Dr. Nupur Giri, our HOD of Department of Computer Engineering, Dr. Gresha Bhatia, Deputy HOD of Department of Computer Engineering, and Dr. M.D. Patel, head of VESIT Research Forum, without whom this entire talk would not have happened in the first place. I would also like to thank all the VESIT staff and scholars for being present here to make this event a huge success. So thank you everyone for being here. In addition to that, I would request all the people attending this talk to please fill up the feedback form that I have shared in the chat link before they leave. Thank you so much.
Well, thank you. I mean, it was indeed a pleasure. I'm happy that Dr. Kumar was able to introduce me to you folks, and have the opportunity. And perhaps in the future we might have an opportunity to have a discussion on something else that I've been working on. But thank you again for your kind words, and I appreciate your
Thank you, sir.
everything that you've done.
Thank you.
Excellent.
Thank you,
Thank
sir.
you very much.
We'll be looking forward for more sessions and more such topics.
I
Yes,
hope it was
yeah.
useful. I mean,
Yes,
my
it
biggest
was.
fear is
Definitely was.
my biggest fear is that this is not something that is typically addressed or even talked about, and it is an absolutely very critical problem and a critical need, regardless of, as I said, which country that you work in. So hopefully it was useful.
Yes, sir. It was. Thank you so much.
Okay.
Okay, sir.
Bye-bye.
I'll get in touch with you after this. Yes,
Okay.
sir. Thank you
Take
so
care.
much.
Bye-bye.
Okay, sir.
Thank
Bye.
you, sir. Bye.
Sure. Lieutenant, we can stop the recording.
Yeah, thank you. Thank you, Sneha. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Richard.